Okay, فthis is physics week 3. طيب, so I'm gonna start. We have two spheres here, each having a charge of 4. What's this n? Yeah, nano. It's times 10 to the what? 9. You need to know this, okay? Nano is times 10 to the minus 9. Micro is times 10 to the minus 6, okay? Don't forget these, because these are asked a lot in these electricity exercises. Okay, so anyways, they gave you 3 charges. You see them? 1, 2, 3. They're arranged in a triangle shape. Basically, they're asking you to find the electric force exerted on the sphere of charge 2 nanocoulombs. So which one is that? That's the one over here. Alright. For the electric force and electric field, I'm going to give you the equations really quickly. The electric field is equal to F divided by Q. This is the first equation. The second equation is that the electric field is equal to KQ over R squared. Second equation. The last equation is that the electric force produced by any two charges is directly proportional to the magnitude of the charges and inversely proportional to the square of the distance between them. Okay, what I just said now needs to be memorized into your heads, because it usually comes select all that apply. Well, that's exactly what it is. What is true about the electric force? You have to say directly proportional to the magnitude of the charges, but inversely proportional to the square of the distance between them. So that is number 3. Okay, so we're going to put that in a box over here. I'm going to call that formula 3. So what are they asking here? They're asking us to find the magnitude of the electric force on the sphere of charge 2 nanocoulombs. Now, how do you have electric force? The first thing I want to explain to you is when you have a positive sphere and a negative sphere, what happens to these two? Hori. Do they attract or repel? They attract, right? So there's going to be a force, let's call this 1 and call this 2. The positive one will pull this one to the left, and the negative one will pull this one to the right, right? So this is the attraction. Okay, now how about if they were negative, negative? What's going to happen to them? Repel. So if you have 1 here, 2 here, this is going to be pushed to the left, and this is going to be pushed here to the right. Right? Got this? So you need this, you're going to apply this concept over here. So over here, you have 4 nanocoulombs. What's the charge of 4? Positive or negative? Positive. This one here 4 also positive. This one 2 is also positive. So this 2, you has a sphere over here 4 and a sphere here 4. It's going to be repelled. Let's talk about, let's call this one 1, 2, 3. Let's talk about 1 and 2 together. How will they behave? Will they attract or repel? Repel. So the force on 2 is going to be in what direction? It's going to be like this or like this? The top or bottom? Top. Perfect. Easy peasy, صح? طيب, okay, this is going to go to the top. Okay? So this is the first force. We're going to call this F12. F12, I'm going to write it here. F12 basically means the force that 1 exerts on 2. طيب, here you have, sorry, this is 2, this is 3, so F13. My bad. Now, you have another sphere here, right? So, Khuri, over here, this second sphere, what's it going to do? Is it going to attract or repel this one here? Repel. So, it's going to go up or down? Up. So, we now have another force. We're going to... What? Okay. We're going to call this force F23. Sahli, right? Easy peasy till now, صح? Nice and easy. طيب, now we need to calculate... We need to calculate these two forces. Right? ما خلصنا. طيب, let's calculate. How do you find F13? What's the formula I gave you? What's the formula? K. ما تنسيها ال K. Right? K. What's K, by the way? Do you know it? 9 times 10 to the 9. You need to know this. Okay? So 9 times 10 to the 9 times the first charge, Q1. Which one are we going to use? Anything. You have 1 and 3. What's the first charge? 4. Do I put 4 or 4 times? Yeah. Times. Wahish. Continue. All over. What's the R here? But do I like centimeters? No. What does it have to be? Meters. Right? Okay, for this centimeters is how many meters? Perfect. Why? We just divide by 100. Huh? Don't forget this, guys. 2 centimeters becomes 0.02 meters. Alright, so 0.02, and is it just, am I done here? What do I have to do? No, square, yes, khuri, square. Okay, now put this in the calculator, what do you get? Let's put it here together. Okay. Let me pause. Okay, so putting this into the calculator, you get this. So we're gonna put 1.84 times 10 to the minus 4. Type F23 khuri, help me out with this one. This one you're gonna do it. Yeah. Yeah. What's the formula? Exactly. Exactly, literally the same equation. Yeah, literally the same thing. Why? Because it's the same thing. 4 and 2 also. Okay? So times 4 times 10 to the 9 minus 9 times 2 times 10 to the minus 9 over 0.02 squared. So you get 1.84 times 10 to the minus 4. Now, you have these two over here. This force. Okay, hold on. You have this force over here, which is F13, and you have this force here, which is F23. Now we need to, add these up somehow, some way. How are we gonna do it? Okay, so I'm gonna take this shape here. I'm gonna put it down over here. Okay, this is a triangle with sides 2, 2, 2. Now, what type of triangle has all sides equal? Do you know what that's called? Alright, now what are the angles in any equilateral triangle? 60, 60, 60, right? Type perfect. So here we're gonna have 60. Here we're gonna have 60. Here we're gonna have 60. وعندك هيدي it goes like this. The force is هيك. We have the other force هيك. Now it's a bit scuffed. Let me fix this a bit. هيك وهيك. So that's how it goes. So if this is 60, what's this angle gonna be? 60 also. I'm gonna make this diagram a bit bigger because it's so small. Okay, هيك عندك 60, 60, 64. We said we're gonna extend this, and that's the force here. We're gonna extend this. That's the force here. So here you have 60 degrees. Now, how do you want to do this? Wallah, it depends on how you want to solve. It depends on how you want to solve. The best thing is, if you want to do it, you need to make an x and y axis. Let's do it like this. We're gonna call this the y axis. We're gonna make this the x axis. Because when you have two forces, you think we can just add them هيك يعني كابيش خلصت? It's done? No, you have to resolve it into two components. What are the two components? X and Y components, right? Okay, so this force here, we're gonna just call it F13. This one here is F23. Okay, you want to resolve it. Now this F13, as you can see, it's already what? Does it make any angle? This one here. So its Y component is equal to what? 0. Its X component is equal to what? It's the force itself. The X component is just the force, right? When I say X and Y component, I'm talking about the force. It's newtons, by the way. I forgot to put newtons. Okay, 1.84 times 10 to the minus 4. Type. This we're done with F1. Let's now do the second one. F23. F23 makes an angle of what? 60. So we want to resolve it into the X component. How do we make it the X component? What do we multiply by? Cosine what? 1.84 times 10 to the minus 4 times cosine what angle? Perfect. Well, Y component is gonna be what? So 1.84 times 10 to the minus 4 times sine 60. Type over here, we now have our x components and y components. So we're gonna have to find the total x component. So fx is gonna be this one plus this one. So let's just do that. So 1.84. I'm just gonna cut and put it in the calculator. So this x component is this 2.76 times 10 to the minus 4. Double y component, since this one is 0, the y component is just gonna be this. So 1.84 times 10 to the minus 4 sine 60. Now how do we find the net force? We do the magnitude. So we're gonna do root. We can take answer squared plus 1.8 in brackets 1.84 times 10 to the minus 4 sine 60 all squared. You get 3. Oh, they got 3.186. So I added something wrong, يمكن. I don't know. I think I put a number in wrong, but it's يعني a small difference على 1 decimal point. It's not that big of a deal. Okay, but that's how you do question 1. So the first step is to summarize. The first step is to figure out the two forces. Once you figure them out using these two steps here, your life becomes way easier. All you have to do is you're gonna get a force like this, a force like this, and an angle between them. Find the angle between them. If you get this diagram in your exam, it's always gonna be 60. I really doubt he's gonna give you anything other than this diagram because it's hard to find the angle. You're gonna have to use trigonometry. What trigonometry isn't, it's not like it's not nice to work with. Okay, but anyways, after that, you're gonna do f1 and f2. Just resolve them into components using your angles, using cosine and sine. This is grade 10 material. Okay, but the hard part is getting to this step here of resolving. Okay, question 2. This is really easy. Now this is an electric field, right? Now electric fields, let's take you back to grade 11 for a second. Electric fields, it always leaves the positive and enters the negative. So if you see that the field lines are leaving a sphere, what does that mean the charge of the sphere is, ya Khouri?
Positive.
Positive. So they're both gonna be, in this case, what?
Positive.
Positive.
I
Easy?
think I'm a genius, bro.
Bro, خلاص easy والله. Question 3. When a 15 microcoulomb charge is placed in an electric field, a force of this is exerted on it. The strength of the electric field is what? So they're asking for the strength of the electric field. This means they're asking for E. They gave me charge. What's charge? What's the symbol for charge?
Q.
Q. Perfect.
Coulombs,
Okay.
I think.
Yeah, in coulombs. Perfect. Yeah. And force is what?
Force is
F.
newtons.
Yeah, F. Alright? So, what was the equation I gave you? It was E is equal to F divided by Q.
Yeah.
Okay? So, this equation, you're going to use it anytime they ask you about electric field. So, substitute everything here. They want you to find the electric field. What's the force?
Wait, don't forget to change the 4.5.
Yeah, exactly. See, and I'm waiting for you to tell me now.
Divided by negative 6.
So,
10 to the negative 6.
which one?
The 4.5.
La. M is milli
Oh,
for 10 to the minus 3. Micro, this one, it looks like the mu, is times 10 to the minus 6. فهلا here, what's the force? Fill it in for me. E is equal to what?
E is equal to 15 over.
كيف الفورس
Yeah.
F newtons.
My bad.
Yeah, so this one is correct. This one's correct. If you thought this was the force and you change this to minus 6 over here, the one on the left. Can you see you can see my screen, huh?
Yeah.
Yeah, this one you change minus 6, this one you change minus 3. Okay? So I think you mixed up which one's the force, which one's the charge.
Yeah, my bad.
Yeah. Don't worry. طيب الفورce, which one is it?
The 4.5. So you divide
Perfect.
it by 10 times 10 to the negative 3.
Alright,
You
multiply. بالضبط. Okay, and Q is?
Q is 15 times 10 to the negative 6.
Perfect. Okay, hello. If you do this on your calculator, you should get 300 newtons per coulomb. The unit newtons per coulomb comes because you're defining a force, which is in newtons, by a charge, which is in coulombs. Okay, that's why the unit is newton per coulomb. Let's do it really quickly. Over here, you get 300. Question 4. You've got two charges, 1 microcoulomb and 3 microcoulombs, are separated by a distance of 2.5. Given that K is this, what is the force between the charges? Khouri, remind me, what is the equation for the force between two electric charges? F is equal to?
F is equal to 9 times 10 to the
Without the
9.
numbers, the formula.
F is equal to, let me just see. E times Q.
Oh, E times Q. That's perfect. That's one formula, but it's not the one I want here. This works, but not here. What is F without E? It's K. Continue.
K
Q1
Q2
divided by R squared.
R squared. Yeah,
Perfect.
right.
Yalla, take this down in your notes if you don't have it written,
Yalla.
okay? This is very important. If you don't remember this, do you know what E is equal to, طيب?
No.
Ah, okay, KQ over R squared. Take these down. I wrote them down for you in question 1. Make sure they're written in your notes. Anyways, so here, which formula are you going to use, Khoury?
Here,
Mm.
the second one.
Second one, perfect. طيب يلا, fill them in for me.
Yalla. Okay, so we have K, which is 9 times 10 to the power 9.
Perfect. يلا, fast.
And then Q1 is 1 times 10 to the negative 6.
Perfect. You got the unit.
Q2
Yeah.
is 3 times 10 to the negative 6.
وحش.
And then R squared.
Which
First,
is
we have to make it in meters.
perfect.
So we divide by 100. So it's going to be 0.025. And then we square it.
100%. Full marks. Now, all you need to do is just put that into your calculator and you should get 43. Let's do it quickly. So you get 43.2 when putting it on your calculator. And what did they ask Khoury to the nearest?
Integer.
So what do you round this
So-
up to?
43.
Perfect. Any questions now?
No,
Perfect.
you're explaining perfect. Best tutor.
Oh, thank you, Khoury. The electric field strength 30 centimeters away from a 5 nanocoulomb point charge is what? So what did I just give you? What did they ask for here?
Electric field.
Yeah, what symbol is that?
E.
What's the formula for it?
F over Q.
Or
Uh,
K Q over R squared. Write this down. Take it down. Okay, حط لك ستار تاني. Write it down. ماشي الحال؟
yeah.
يلا. Now that you know the formula, is it really hard to apply it?
9 times 10 to the power 9
Yeah.
times 5 times 10 to the power negative 9.
Perfect.
And first we have to make the 30 in meters, so 0.3 squared.
Perfect. يلا. You're doing great. Anjad, you're doing great. 45 divided by
Thank you.
0.3
But it's
squared.
all the tutor.
No, well, it's not. 45 divided by 0.03 squared. Sorry, 0.3 squared. You get 500. Yeah. Till now, what do you need to know? Once you know the formula, خلاص يا خي كل شيء بيزبط معك. Okay, don't forget the formula. أهم شيء. Okay, this is an easy question, but it might look a bit scary. Okay, so read this really quickly.
The diagram below shows the electric field lines in a region of space between the charges.
Alright. The point at which the magnitude of electric field is the weakest and the point that is closest. Okay, let's forget about I. But for now, they're asking for where the electric field is the weakest. طيب, I'm gonna give you two. I'm gonna. Alright, it's point Y. Yeah?
Of course it's Y
Yeah,
because
yeah.
it's not on the lines, you know, and it's the farthest
No,
away.
actually, ما خص. It's not about it being on the line or not.
Actually?
Yeah. طب, let's say the Z was. You see, the Z isn't on the line. It's positioned in between these two lines. Yeah?
Yeah.
Okay, let's say the W was here and the X was over here. Oh no, actually, let's say the X was a bit closer. This, now they're not on the line and the answer is still Y. Do you know why?
Why?
Here's the thing. When, let's say you have your object here, مش راح positive, يعني they leave the positive. When you have lines that are spaced out like this, as opposed to lines that are close together like this, you see that's a Z. It might not look like a Z, but it's a Z, trust me, it's a Z. Which one has a stronger field, X or Z?
Z?
Z. Z here is stronger. What's my point? You need to know the electric field will be stronger when the lines are what? Closer or farther?
Closer.
Lines are closer.
Ah, I see it now.
Okay, now look at these points here. They're saying which one is the weakest. So do we look at closest or furthest?
Further.
Furthest. So here, look in Z, the lines are like cramped together. You see them? In W, they're sort of cramped together. When X, it's on the line. It's يعني هيك. If you look at Y, look at where it is. It's in between. X passes because it's literally on the line. Okay, that's different. But when you have it and it's spaced out like these lines are spaced, you need to know that that's a weak electric field. You got that?
Yeah.
Okay. Now the point that is closest to the positively charged object is what? Now over here, these lines are leaving or entering?
Leaving.
Leaving. So what does that mean? Where's the positively charged particle? On the right or left?
Right.
Right. Why? Because it always leaves the positive. So which one's closest to the positive particle? Which point?
Z for Z, bro.
Z for Z. بالضبط زي دخولي. Okay. طيب, now part B, select the arrow that correctly shows the direction of the electric force on the electron, on an electron. Okay, I'm gonna circle electron placed at point W. طيب, electron is what? Positive or negative?
Negative.
طيب.
So it attracts.
So okay, sure. You could say that. Here we said that it's positive, right? So an electron, will it go according to the flow of the electric field or opposite to the flow of the electric field? Always against. Because this is all positive lines. Always in electric field, the lines show you where the positive will go. If you came and told me electron, yani, am I talking about positive anymore?
No.
No, it's actually negative. You gotta do the 180 degrees, okay, and lock in. For now, it's gonna be the opposite direction. That's why it's this. You get that?
Yeah.
So why isn't it the one above it?
Because the electric field is going down.
Perfect. Which actions can possibly decrease the magnitude of the electric field at point W? Now, let's take a look. Place a negatively charged object at point W. Place a positively charged object near the upper left corner of the diagram. Placing a negatively charged object near the bottom right corner of the diagram. Okay, so let's take a look here. I'm gonna explain the ones that are correct and then cancel out the ones that are wrong. The one here that's correct says place a positively charged object near the upper left corner of the diagram. So over here, if you put a positive object, ماشي, what's gonna happen to the electric field lines? Do they go towards it or run away from it?
Run away from it. No?
Positive, they always leave, right?
Yeah.
100%. Good job. So if they're gonna leave, are these field lines gonna be going here anymore?
Nope.
So exactly. So over here, we're gonna have these ones going out, and these ones, are they gonna be keep on going in this direction?
They're gonna repel.
No, so they're gonna change. They're gonna change direction. بالضبط. So over here, yeah, if it's going here, it's not gonna go up anymore. You have an object here, or it can go up هيك. But
Yeah,
it can't cross this positive space. You know what I mean?
Yeah.
Okay. So they're saying they want to make point W how much?
0.
0. So basically, no more electric field. So this one's correct. لأنه هيك, you put it positive. Now you need to know, to have a 0 electric field, that means there is there is two. No, I'm not gonna say two lecture. There is a neutral point. I'm just gonna say neutral point. Neutral point means a region where 0 electric field passes. And in this case, when you put the positively charged object on the top left, that means it's not gonna pass through there. There's gonna be 0 electric field. Do you get what I mean?
Yeah.
Okay. Now let me show you the second one. Hold up. Let me erase this. Placing a negatively charged object near the bottom right corner of the diagram. Let's take a look here. Over here, negative object on the bottom right corner. What's gonna happen to electric field lines? Do they go towards the negative or run away from it?
Go towards it.
So all of these, are they gonna go up anymore?
No.
Where are they gonna go?
Down.
They're gonna go like this. So looking at W, are we gonna have anything that goes there?
Nope.
No. So that's why these two are correct. Now let's take a look at the ones that are wrong. Placing a negatively charged object at point W. بالعكس, if you put a negatively charged object at point W, what's gonna happen to all of them? They're gonna go where? Exactly. بالضبط. Exactly. See, you got that. Very good. Placing a magnet near the bottom left corner of the diagram. شو خاص? We're talking about what here? Electric field. Right? Electric field. So would placing a magnet change? Are we talking about magnetic field? We're talking about electric field. Let's not You know, let's not mix two things up. Reverse the sign of all charges creating the electric field shown in the diagram. So they're saying, reverse the, what's creating the electric field here, by the way? What type of charge? We said over here we had what?
Positive.
Positive. They're saying reverse the charge. If you reverse it, what's gonna happen? It's gonna become what?
Negative.
Type. If it's negative, what's gonna happen to these arrows? Are they gonna change direction, or are they just gonna go and move in the opposite direction?
Move in the opposite
So they're not gonna go left or right or divert. They're literally just gonna go from this to this. Yeah?
Yeah.
So is there still gonna be something passing through W?
Nope.
Bella.
Oh, my bad.
Yeah.
Yeah, the
It's just,
negative.
instead of going up, it's just gonna be coming down. You know what I mean?
Yeah.
Alright. So would that reduce the electric field to 0 at point W?
Yeah.
Keith, I told you it's still passing through W.
Oh, my bad.
Okay, you know what? let me draw this one more time here. This we said is for positive. Let's say I redrew the same thing but negative. So the electric field lines are gonna here عندي ال W, here عندي ال X, هون عندي ال Z. I made this negative. Where the electric field lines gonna go? They're gonna go towards the negative, right?
Yeah.
So it's gonna go like this. I'm just copying these same ones, but instead of going out, they're going back in.
Yeah.
So W, is it getting action?
No.
How no?
Yeah,
It's
sorry,
on the line. شايف? Do you get this?
Yeah.
100%?
150%. Guys, I'm sorry if I'm being a dumbass.
No. يا الله. Don't worry about it. يا أخي عادي. بالعكس, they learn from your mistakes يا أخي. Positively charged sphere 1 is placed in contact with a neutral metal sphere 2. So you see this is the positive one. And they said that the sphere 1 has a charge of 2000 E, where E is the elementary charge and they gave it to you. Alright? Assume spheres 1 and 2 are identical. What is the direction of motion of charged particles between the spheres? Type over here, what charges do I have? Sphere 1 is what?
Positive.
Sphere 2 is?
Negative.
I
think.
Neutral.
Neutral.
Okay, neutral. So the charge on it is what? In other words, 0. صح?
Yeah.
Okay, طيب ليك. They're saying when they put them in contact, what is the direction motion of charged particles between the spheres? طيب انت, you know, do protons move?
Nope.
No, what's the thing that moves from one sphere to the other?
Positive charges.
But positive charges are protons.
Sorry.
The
electrons.
Electrons. So the only you need to keep it as a note.
Sphere 2 to sphere 1.
Hey, so
That's
electrons
from sphere 1 to sphere 2.
are the only particle that move.
Yeah.
Okay, keep this for you as a note. You need to know this. Type, okay,
Yes.
if electrons are the only particles that move, Khuri, as this one, the positive one, who already, if something is positive, does it have excess electrons or a deficiency in electrons?
Deficiency.
Deficiency. So is it gonna lose more electrons?
Sphere 2 is gonna lose electrons.
Okay. So since sphere 1 is already positive, would it make sense for it to lose more electrons?
Nope.
No. So which one's gonna lose electrons?
Sphere 2.
So sphere 1 would be gaining them. So that's why sphere 2 to sphere 1. Is this clear?
Yeah.
Okay. Now here, in terms of the elementary charge, the charge on sphere 2 becomes what? So let's take a look here. The charge over here is what? 2000. Yeah? E.
Yeah.
The charge over here is?
You don't know.
No, they said it's what?
Neutral. So
Which
0.
means 0. So we put them in contact. So they're gonna keep on transferring until both sides are the what?
Or 0, no?
No, keep 0. If one's 2000 and the other one's 0, you can't make both of them 0 unless you release them outside to the other world. But as long as you're stuck here, they're gonna keep on transferring electrons until Khuri, they have the same amount of charge. ماشي?
Yeah.
Okay, so if you have 2000 here or 0 here, where are they gonna stop? Where do you think?
1000.
1000. Did you take that from the answer?
No, but that is like there's two spheres. Okay.
Yeah.
2000 over 2. It's
Okay.
the average.
Yeah, exactly. You literally take the average. If this was 100, how would you do it? 2000 plus 100 all over 2. That's how you do it. ماشي? Got it?
Yeah.
يلا. What else can I explain? Okay, so you got the 1000 part. Now here, what is the charge on sphere 1 after they are separated. Okay, here this is the charge in terms of E. Okay,
Yeah.
when we talk about something, what's this called? The E, what does it stand for?
The E,
Yeah, it's boxed here.
element.
Elementary charge.
Yeah.
You need to know that charge Q, it comes from multiplying the number of electrons by the charge of one electron. Does that make
Yeah.
sense? What gives an atom its charge? The number of electrons inside it. And each electron has a specific charge called E, which is the elementary charge, which is given here. So when I say it's 1000 E, I'm talking about my
Yeah.
Q, it's 1000 E. Now they're saying, okay, I don't want it in elementary form anymore, I want it in Q form. So what do you have to do? Literally just multiply 1000 by E, which is what?
1.6 times 10 to the negative 16. No.
Yeah, no, here it's negative 19, right?
Yeah, so, but once you multiply it, it becomes
Yeah.
negative 16.
Yeah. Do you get this part here?
Yeah.
Alright, so basically we said the charge on sphere 2 and sphere 1, they're both equal after they touch for a long time and whatever, right?
Yeah.
So sphere 1 will also have 1000 electrons, correct?
Yeah.
So what will the charge be if it's 1000 electrons? I told you, what you have to do, all you have to do is just multiply the number by what? By the E, which is always going to be given. ماشي?
Yeah.
Got it?
Yeah.
Okay, question 8. Alright, take 3 charges. Q1 is positive, Q2 is negative, and Q3 is negative 2 times Q. فهمت شو قصدي? You see this here? Read this here really quickly.
Which Q1 plus equal plus Q. I can't see that.
Let me. Can you zoom in or do I zoom in? I'll zoom in. Here.
Q1 equal plus Q, Q2 equal negative Q, and Q3 equals negative 2Q.
Okay. You see them here? They're on the graph.
Yeah.
Alright. طيب. What are they asking you to do? Drag and drop the correct arrow that shows the direction of the net force acting on them. Whatever. Okay, let's talk about Q1 and Q2. Let's ignore these here. Let's focus here. Do you see this? The circle I drew? Type. What's the direction of the force for Q1 and Q2? Are they going to something or something? What are those two somethings? If something's positive and negative, what's gonna happen to them? They're gonna what? Attract. So the direction of force on Q1 is gonna be to the left or to the right? If they're gonna attract, yeah?
The right.
Yeah, to the right. Why?
Because it's attracting.
Okay. Q2?
Q2, it's gonna be to the left because also it repels from Q3.
Okay, yeah. Let's forget about Q3 for a sec. But Q1 and Q2, I told you they're gonna attract each other.
Yeah.
Got that?
And then Q3 is to the right because it's repelling from Q2.
Perfect. You got this?
Yeah.
So over here, these are the answers. You get this? Right, left, right. Now, B, rank in ascending order the magnitude. We're gonna rank in ascending order. Basically, we want to rank the forces on each charge. To do this, to make our work organized, since there's a lot of, bullshit, we're gonna do it one by one. Okay, on Q1, there's two forces. There's the force attracting it to Q2, and there's the force attracting it to Q3. So I'm gonna do it one by one. First, I'm gonna do F21. What is it? It's gonna be K Q1 Q2 over R squared. I'm gonna keep it in this term. Okay, now this here, since it's negative, you still keep it as positive. Okay, never put in a negative charge, it's always positive. Okay, so first I'm gonna keep it in terms of K because I don't have any numbers, and I'm gonna keep it in terms of Q because again I don't have any numbers. So I'm just gonna keep it as K Q squared over R squared. So this is the first one. I'm just gonna call this F. Let's call it F. Okay, now how about the second force, which is the one that's being exerted from 3 on 1. F31 is equal to K Q. First one is Q. The second one is negative 2Q. So do I put negative? No. So I just put 2Q over R squared. The R now is 2 is 2r all squared. Why? Because the distance doubled, so it's 2d instead of d. Alright, so we're gonna get k2kq squared over 4r squared. 2 over 4 is 1 over, you cancel them, you get kq squared over 2r squared. Now, kq squared over r squared is f. Kq squared over 2r squared is f over 2. In other words, 0.5 f. Why? This is the same thing, but you're dividing by 2. Why am I doing this step? Do you need to know it? No. You can just keep it in terms of these, but this is going to make my work easier if I have f 0.5 f. So we're done with q1. Now q2. Let's go to q2 and erase everything that's here already. q2 has a force pulling it to the left or a force pulling it to the right. Let's take a look. The force pulling it to the left is going to be f1 on 2, which is the same as this here. Alright? It's going to be kq squared over r squared. So it's going to be f. Let's just say f. The second force is f3 on 2. How do we find out? It's q3, q2. So what's the formula? K. q1 is q. q2 is negative 2q. So we're going to keep it as 2q. Over the distance between them, is it 2r now? No, it's just r because it's 1d. So r squared. So it's going to be 2kq squared over r squared. We said kq squared over r squared is f. So 2kq squared over r squared is the same as saying 2f. What's the net force in the first one? I didn't write q1. If we had f and 0.5 f, they're both acting in the same direction, right? So they're going to add up. So the net is going to be for q1 1.5 f. For q2, the net is going to be 1f. Someone's going to tell me, why is it 3f? Let's see. q2, you have the force going to the left and the force going to the right. So do you add them or subtract them, Khoury?
You subtract.
You subtract them. So that's why 2 minus 1. Okay? So the net on q2 is 1f. And let's take a look at q3. q3 has two forces that we already found. You have this one repelling it from 2 and the one attracting it to 1. The one attracting it to 1, we're going to say it's f(1,3), which we already found. It was 0.5 f. Okay? And then f(2,3), which we already found here, which is 2f. Now, one's going to the right, one's going to the left. So do we subtract or add? Subtract. So we get 1.5 f. So let's rank it in increasing order. Label 1 for the lowest net force. Which one has the lowest net force? 1.5, 1, 1. Which one's the lowest? 1. So which one's going to be the lowest? q2. So we're going to... 1 and 3 are the lowest net force. What? Okay, I made a mistake over here. The two forces on q2 are in the same direction. Because... and I said it was 1 to the left, 1 to the right. This one to the left is because the positive is attracting the negative. Now, how is the negative attracting the negative? So it's wrong for me, it's being pushed to the right by the negative. The negative will also repel it. So it's also going to be in the left direction. So instead of 1, it's going to be 3f. Okay, so now the weakest one is this 1.5 and this 1.5. So they're going to be 1, 1. And then the greatest one is going to be q2. So it's going to put the 2 forth. Alright, the carriers of charge on the negatively charged sphere as what? And obviously this is what carries negative charges. It's electrons. Alright, this question here is a lot like question 1. I'm going to skip all the details. I'm going to just go directly into solving. So you have 3 charges, these 3. You have 2 negative ones, 1 positive ones in a, what is an equilateral triangle. Okay, the electric field, they want the net electric field at y. Okay, so the electric field at y, you need to know it's positive. So the electric field will be leaving it or entering it if it's positive. It should be leaving it, like this. Okay, so these two are the electric field vectors produced by z and produced by x. So you need to know, you need to be able to calculate it, yeah? So let's take a look. We're going to do the electric field by z and y. How do you do it? It's formula Khuri, do you know what the formula is for the electric field? It's KQ
Yeah, we
over
did.
R squared. So looking at Z and Y, it's going to be K 9 times 10 to the 9 times Q produced on Y. So it's going to be, let's see here. Hold on. Yeah, so it should be times, we're looking at the electric field on Y. The charge associated with we're associating it now with is Z. So it's going to be multiplied by Z, which is negative 200, well, بلا negative 200 times 10 to the minus 6 over the distance squared, which is 1 squared. Put this in your calculator, you should get 900. Okay, this is negative, sorry, 1800. 1800. Now this is the first one. This is over here, zy. Now let's do this one here. It's gonna be same, so we're gonna call this E1. E2 is same formula, 9 times 10 to the 9 times this one here, 100 times 10 to the minus 6 over distance squared equals 900. So this is 900, this is 1800. Now we want to find the net electric field. How do you do it? So easy. You now have both electric fields. What's the angle between them if they're an equilateral triangle, Khoury?
60.
60. طيب, what do? You just resolve it. You have this one here, هيك, this one هيك. This one was E1, this one was E2. You have 60. So let's see, E1, Y. What's its Y component going to be? What do you think? It's going to be 0. Alright, E1X is going to be, since there's no Y component, it's just going to be the value of E1, which is 1800. Now E2X is going to be E2 times cosine of the angle. So it's going to be 900 cos 60. E2Y is going to be E2 times sine 60. So it's going to be 900 sine 60. So we want the total electric field. How do we do it? We add them up and then find the magnitude. So it's going to be root. The total x component is going to be 1800 plus 900 cosine 60. We're going to square that. Plus the total y component, which is 900 sine 60. Square that as well. Now, putting this in your calculator, you're going to get you should get let's do it together. Wait, I'll cut to it. Okay, so you're gonna get 2381, and they want it to one decimal place in kilo. So if it's in kilo, you divide by 1000, and you're gonna get 2.4 to one decimal place. The net force on sphere Y is what? If this if this is the net electric field, 2400, you can do that E is equal to F over Q. So F is just going to be equal to EQ. So it's going to be 2400 times the total charge. The total charge is the charge on it is just going to be 200, because 2 times 10 to the power, sorry, 200 times 10 to the minus 9. Very easy. And after you get part A, part B is very easy. You just do F is equal to EQ 2400 times 200 times 10 to the minus 9, because this is the charge of Y. Doing that on your calculator, you get 0.48 millinewton. How? Because you should get I think you get 4.8 times 10 to the minus 2 on your calculator. You get this. Okay, making this in milli, you multiply by 10 to the minus you multiply by 10 to the power of 3, sorry. So you're gonna get, hold up, no, you get fuck, let me do this on my calculator. I'm not gonna do anything from my head, I'm not a calculator. 2400 times 200, sorry, times 200 times 10 to the minus 9, you get this, and then milli you multiply by 1000, so you get 0.48. That's it. So you don't do it in your head. For part B, it's really easy. You have this vector going like this. They're saying the net force direction on the sphere, net force on sphere y. Okay, since you have it going like this or one like this, obviously the net is just gonna go through the middle. You can do any method to add them, it doesn't matter, but it's gonna be going through the middle. Nice and easy. Suppose now at t equals 0, all the spheres are released from rest. Which of the spheres will have the greatest initial acceleration? Y and z. Why is it y and z? Because they have the highest charges. Okay, that makes sense. Okay, when a neutral plastic rod is rubbed with a piece of fur, the rod acquires a negative charge of this, where E is the elementary charge. Okay, this E. Take E equals this. Type. If the plastic is becoming negative, what's moving أول شيء? What moves? Protons or electrons?
Protons.
Yeah, Zaid.
I said electrons.
Khuri. Bro, stop. Lock in. It's electrons. Yeah? Type. They move from where to where? هلا if the plastic is the one becoming negative, يعني where's the electrons going inside who? Which one is gaining electrons? The plastic, right? Yeah, the rod, exactly, the rod. So, obviously, since the rod is becoming negative, the plastic rod is becoming negative, so where are the electrons going to move from the fur into the plastic rod? تمام?
Yeah.
Okay. B. Once rubbing is finished, the charge on the rod to 1 decimal place becomes something, and the charge on the fur to 1 decimal place becomes something. Therefore, one can conclude that the total charge... Yep. Okay. Here... Understand. What's the charge of the rod here?
2 times 10 to the power 10.
What?
Electrons.
E. Okay, so they're saying now, they want it in terms of electrons now. What are they asking for, Awalshi? They're saying the what?
The charge.
The charge. Can you keep it as this?
Nope.
No, so what do? You have to multiply this by?
1.6 times 10 to the power 19.
Perfect. And you get? This. Now tell me why it's negative.
Because electrons are usually negative.
They said here, it's what?
Negative.
Type, okay. This is the charge of the what? The?
Electrons.
The rod. Okay, this is the rod that got this. Now, they said, okay, the charge on the rod after you get it. Then they want the charge on the fur. Okay, the charge on the fur. What happened? What's the experiment here? The fur gave the plastic rod its charges. So, is it going to be positive or negative, the fur? If the fur... Yeah, positive, right? طيب. They both started at what? Neutral.
Yeah.
So 0, 0. So when the plastic rod gained electrons, what's the charge? If it gained 3 electrons, so it's gonna be 3 minus on the plastic rod. So what would the fur be? If this one's 3 minus, what would this one be? What do you think?
3 plus.
3 plus. Perfect. So same thing here. We got the charge of the plastic rod is what?
Negative
3.2 nanocoulomb. Okay, it would be times 10 to the minus 9 in your calculator. That's why it's negative 3.2 nanocoulomb. Understand?
Yeah.
Alright, so we said since it's the plastic and the fur, how much would the fur be if this is negative 3.2? This would just be what?
Positive 3.2.
Yeah.
So basically just 3.2.
Yeah, so the opposite. So therefore, one can conclude that the total charge on the rod fur system becomes 0. Why is it 0? What's the total charge? What happens to these negative 3.2 and positive 3.2? Add them up. What's the total charge?
0.
0. So the system is always 0. This is true for any system. If you have A and B, A is plus 3, B is plus 2. Let's say after it, A becomes plus, I don't know, 1. How much will B become? What was the total here? Plus 3 plus 2.
Plus 3 plus 2.
What's the total?
0, no?
No, I'm giving an example. Let's say a system started like this.
5.
What? 5. So that means the total here should also be what?
5.
5. So if this is plus 1, how much will this one be? Plus
5.
The total should be 5.
Oh.
Okay, well, I told you that A became now plus
2.
1. So plus 4. Okay, 1 plus 4.
صح.
Okay, always remember Q is conserved. Okay, anything that ever happens. So the charge before will always be equal to the charge after. In this case, the charge before was what? It started as what?
0.
0. In this case, you got negative 3.2 on the plastic rod. So how much will the fur be? I don't want to play fur. Take negative 3.2. It's math. Take negative 3.2 to the other side. You can get F is equal to 3.2. So this one's also 3.2. I just proved it for you. You need to know this. Okay? That the total charge on the system will always be conserved. You'll never see it changing. So if the start was 0, the total at the end will also be 0.
Yeah.
Question 11. Consider two identical spheres of the same charge separated by a distance of 1 centimeter. The magnitude of the electric force between the two spheres is 90 Newton. What's the magnitude of the charge of each sphere? Okay, I want you to help me out here. Alright?
Yeah.
Alright. So what are they asking for? They want the
Charge.
So they want Q. They gave me what here?
The force.
The force. They gave me what here?
R squared. So
R.
resistance.
Not R squared. They gave us R. Well, you square it yourself. Okay. So they want F. Sorry, they want Q. They gave me F. They gave me R. Now these two spheres, they are what?
Identical.
Okay. So what's the formula for FQ and R? What is it? F is equal to K.
S K Q1 Q2 over R squared.
Right? Type. These two charges are what? Identical.
Yeah.
So do I write Q1, Q2?
Yeah.
Okay,
no,
yeah.
Q squared.
Q
You write
squared.
Q
بالظبط.
squared.
So it's gonna be F is equal to K Q squared over R squared. Since they're identical, they're the same charge. So we write like this. Now, do I have all these values? Let's take a look.
Yeah.
We want to find Q. So do we have the F? What's the F?
F is 90.
90. Perfect. K is what?
K is 9 times 10 to the power 9.
Perfect. Q squared, we don't know it. We're trying to find the charge, right? Over the distance between them squared. What's the distance between them squared?
0. We have to make it meters, so it's 0.001.
Hey, no, not 0.001, just 0.01.
Okay, and then you
Square.
square.
Now, to do this, we put it on our calculator. Times 90 divided by 9 times 10 to the 9, then square rooted 1 times 10 to the minus 6. Don't forget the square root since it's Q squared, okay?
Yeah.
Okay, perfect. Question 12. Two identical neutral spheres are separated by 1 centimeter. Electrons are removed from one sphere and transferred to the other until a force of this is generated between the two spheres. How many electrons were transferred in the process? So, again, we have a force being produced. We have something to do with charges. We have the distance. So which formula am I going to be using? F is equal to... Anytime you see any question like this, force and distance, what's the formula? F is equal to what?
K
K
Q1 Q2 over R squared.
sorry, K Q1 Q2 over R squared. Now again, they both have the same charge because they're two electrically neutral spheres. Okay? Got it?
Got it.
So they're both the same charge. So we're instead of Q1 Q2, what are we gonna say?
Q squared.
Q squared. So it's gonna be F is equal to K Q squared over R squared. كفي. F is قد ايه F?
F is
This,
1
right?
times 10 to the -6.
Equals K is what?
K is 9 times 10 to the power 9. And then the
Q squared, we
is,
don't know it. Because they're asking us how were the electrodes.
Yeah.
Basically, that means they're asking us about the charge. Over R squared, what's the distance between them?
0.01 squared.
Okay, now, solving this on your calculator, you're gonna get Q is equal to 1.054 times 10 to the negative 10. Okay, this is what you get Q as. تمام? Now, Henry,
Yeah.
what do they want? They want the charge or they want the electrons?
The electrons. No?
Electrons, yeah? And charge is equal to the number of electrons times E. Remember this? Do you remember this?
Yeah.
Okay, so how do I find the number of electrons n? I just have to divide this by what? By E.
Yeah.
Okay, now Inta, you might ask me, what's E? E, usually it should be given to you, but it's 1.6 times 10 to the power of negative 19. Okay,
Write it down. Write it down.
okay. So, to find n, it's just going to be equal to Q divided by E. So it's going to be 1.054 times 10 to the minus 10 divided by 1.6 times 10 to the minus 19. And you're going to get at the end 6.59 times 10 to the power of 8. Is this good?
Yeah.
تمام.
Live, love, Watfa.
Inshallah. Alright, 13. Spheres A, B, and C have the respective charges of this, this, and this. I don't know why it's labeled like that. It confused me for a second. What is the net force on sphere B due to spheres A and C? So let's take a look at spheres B. Sphere B, okay? Alright,
Okay.
let's quickly put A is what? What's the charge of A? Positive or negative? I don't care about the value for now. I just want to know the sign. A is?
A is negative.
B is?
Positive.
B was what? What'd you say?
B was positive.
Alright.
And C is negative.
C is negative. Okay, so we're looking at the net force on what sphere?
On sphere B.
Alright, so how's it gonna be? Oh, actually, the first force on B due to sphere A is gonna be to the left or to the right? Due to sphere A.
To the right.
Alright, let's think about this, yeah? Sphere A is what? Negative. Sphere B is
Yeah.
what?
Positive.
طيب انت ask yourself, negative, positive, should we see here?
Due to sphere A, I thought in general
Yeah.
it's gonna be to the right. Because of
To the right?
distance. It's gonna be to the left.
To the left. Because they're what? They
Yeah.
are attracting, right?
Yeah, because they're opposite charges.
Yeah, opposite charges. Now, how about C? It's also what?
Attracting.
Attracting. So we have a force like this, a force like this. So we need to find the forces one by one, and then we're gonna add them or subtract them. What do you think?
Add them.
How add them if one's going to the
sorry,
right, one's going to the
subtract
left? Subtract them. FAB type. So force of A is gonna be what's it equal to? The formula of any force. If you have the distance and you have the charge, what is it?
K
Mm-hmm.
Q1 Q2 over R squared.
All right.
I'm learning.
Perfect. This formula I need you to know it like your dad, like your name. Okay?
Rabia?
Maybe. 9 times 10 to the power of 9 times. What's Q1 in this case?
5 times negative 5.
La,
times 10
I
to the
told you we don't
power.
consider.
It's absolute.
Yeah. Perfect. You got it. Good job. With this one here,
10 times 10 to the power 6. It's already positive.
negative. Only negative 6, huh? The powers are negative.
Oh, yeah.
Okay,
I don't show
over.
that well by day.
Yeah, I know. Wallah. Over the distance, we have to make it into what?
Meters.
Alright,
So 0.06.
squared. Now, doing this on your calculator, you should get. Wait 1 sec. 125. Okay. Now, second one, there's now this force C on B, right? So it's gonna be K Q1 Q2 over R squared. Help me fill it in. Yalla, Khuri.
Okay, so 9 times 10 to the power 9.
Mm-hmm.
10 times 10 to the power negative 6.
Mm-hmm.
And 12 times 10 to the power negative 6. And yes, it is absolute. That's why it's 12.
Perfect. Wahish. Over.
Over 0.04 squared.
If you don't want to do this on your head, please use your calculator. It takes you 3 seconds. Type doing this on your calculator, all of this, you get 675 Newton. Now, what do we do with these two? We add them or subtract them?
Subtract.
Okay, so we subtract them, you get 550. In what direction?
The right.
Why to the right? Because this one here to the right is 675. This one to the left is 125. Got it?
Yes.
Yalla, 14. Inshallah, easy questions. I think 15 is a bit long.
Oh my god.
It's not bad, it's not bad. طيب يلا 14. Three charges Q1 equals 10, Q2 equals 50, and Q3 are positioned in a way that the net electrostatic force on charge Q2 is 0. What is the magnitude of charge Q3? So they're saying that the net force on Q2 is 0. So this force here is equal to that force on the left. So let's take a look. They told us Q1 is positive, so I'm going to put a plus here. Q2 is also positive, and Q3, well, they didn't tell us what it is. They want us to find it. Okay, so we don't know what it is. Now we know that our sheet, this positive and this positive, they repel. So it goes to the right. Now they're saying that the net force on Q2 is what? 0. So if the net force on Q2 is 0, that means will the other force done by Q3, will it also be in this direction, or will it be in the opposite direction to cancel it out? What do you think, Khoury?
Sorry?
Here we have Q3, right?
Yeah.
Okay, it's going to produce a force on Q2. They said that the net force on Q2 is 0. So would that force be like this, or will that force be like this?
Like that, because it's repelling.
Alright, perfect. It's going to repel, exactly. Since it's repelling because we want it to be 0, that means we need a force on the other side to cancel this one out. This is the F1 on 2. This one here is F3 on 2. Now, they told us that the net charge is 0, so let's take a look. Net force is 0, so that means F3 on 2 is equal to F1 on 2. Type, what's F1 on 2? Can we find it? Of course we can. Khoury, what's the formula to find any force?
I'm getting bored of saying it, but F equal K Q1 Q2 over R squared.
So 9 times 10 to the
Now
9.
I know it like Rabia, just clarify.
Yeah, okay. Times Q1, which is 10 times 10 to the minus 9. Why? Because it's in nano, times Q2, which is 50 times 10 to the minus 9, all over R squared. So it's going to be distance between them squared, so 0.02 squared. So it's going to be 0.01125. This is the value of F12. Now we said that F12 and F32 are equal since the net force is 0. Okay, so since they're equal, can I find Q3? Of course I can. So F32 we said is equal to 0.0125. F32, the formula for it is KQ2Q3 over R squared. So let's fill it in and then we can find Q3. Let's do it. 0.0125 is equal to 9 times 10 to the power of 9 times Q2, which is 10 times 10 to the minus 9 times Q3, which we don't know it, all over the distance between Q2 and Q2 is 50, not 10. Okay, times Q3 all over 0.06 squared. So you get Q3 after solving this to be 90 nanocoulomb. On the calculator it gives you 9 times 10 to the minus 8. So in nano, because they want it in nano, you just multiply by 10 to the power of 9, you get 90. That's question 14. Now question 15. Okay. Wallah kiss me again. It's okay. بسيطة خير بسيطة. Okay. So you have 2-point charges, Q1 and Q2, and they're located at these positions. 0, minus 2, 4, 0. Okay, so let's draw this. Okay, 0, minus 2, yani 0, minus 2. So here is Q1. It's minus 2. والتاني plus 4, 0. So 1, 2, 3, 4. This is Q2. Okay, ID4. Give your answer to 2 decimal places. What do they want? They want the magnitude of the net electric field created by the 2 charges at the origin of the coordinate system. Let's see. So we have 2 electric fields being created on the origin. So it's gonna be the one E1 and E2. So let's find them one by one. What is how can I say this? Yeah, so you're gonna want to find E1 and E2. So all you have to do is the formula for the electric field. You have you have the charge, you want to find the electric field, and you have the distance, they gave you the coordinates. So E1 will be KQ1 over R1 squared. And we're talking with respect to the origin, so with respect to 0, 0. K is always 9 times 10 to the 9. Q1 is 5 times 10 to the minus 9. Over R1 squared. What's the distance between Q1 and the origin? Khuri, what's the distance between these 2 points?
Distance.
Yeah, between the origin and -2. What is it?
-2 in the y direction.
Yeah, so you just say the distance is 2. Now, we have it in centimeters. Can we keep this in centimeters?
Nope.
So 0.02 squared. Here, KQ2 over R2 squared. So 9 times 10 to the 9 times Q2, which is 10 times 10 to the minus 9. All over the distance. What's the distance between this 0 and this 4, Khuri?
Sorry?
What's the distance between the 0 and the 4?
4 centimeters.
But do I put it as 4?
Nope.
So
Put it at
0.04 squared. So this is gonna give you E1, which is equal to 112500. This is gonna give you E2, which is 56250. Now this is in the x direction. In the y direction, because Q1 is like this, down. Well, this E2 is gonna be in the x direction, because it's like this. Type. How do you do it? You now have a y component and an x component. You want to find the magnitude, you just do root 112500 squared plus 56250 squared, and you're gonna get your calculator is gonna give you this 125,778.8. They want it times 10 to the 5, so divide this by 5, divide this by 10 to the power 5, 1, 2, 3, 4, 5, you get 1.2. They want it to 2 decimal places, so we're gonna run to 1.26 times 10 to the power 5. This is it. هيك بنكون خلصنا. If you made it this far, good luck in your physics exam tomorrow.